And welcome to our third and final advanced breakout session at Knowledge Aware. It's a knowledge aware approach to smart CAD with Auros Knowledge Systems. Kamyle or Jamil? No, let's combine the names. Jamil Caxon? No, Kamyle Jackson. Come on up. Let's give it up for her. Come on, yeah. There's your clicker. Perfect.
Thank you.
Yes.
Hello, everybody, or good afternoon. As Amy said, my name is Kamyle Jackson. I'm just going to go over a smart CAD presentation real quick. So let's get into it. So first, we have our Auros Smart CAD Vision. So basically, it's a single source of truth for lessons, standards, requirements that actively informs every model. So by doing this, it results in reduced effort levels, improved communication, and expanded opportunity for new learning. So what we're going to go through now is we're going to go through the maturity level for Smart CAD. So first, we have our experience dependent. So this is basically saying your parts are modeled based on the experience of the individual that's designing that part, right? So as far as parameters, there aren't any parameters, there's no intelligence. You may have an Excel-based check sheet somewhere that may or may not be used. As far as conformance or compliance reporting, there isn't any. There's no look across also. And then as far as knowledge management, there is no knowledge management. The knowledge is based on the person that is up there doing the designing. So we're gonna go to our next maturity level, which is our check sheet supported. Basically, that just means you have an external check sheet, probably in Excel somewhere, that you use as a backstop to model, to your model reviews. So your designer goes in, they're doing their CAD modeling, and then eventually they're like, oh yeah, I got that check sheet somewhere. I need to make sure that what I just designed actually matches it. So that's what this level of maturity is. As far as parameters, there may be some, but they're very inconsistent across your programs. You do have your Excel-based check sheet, but if you want to do any reporting, it's very manually intensive, so meaning you're gonna have to go find all of those check sheets somewhere, hope it was filled out correctly on top of that, and then get all of that data from those to try to make a report. As far as knowledge management, you have uncontrolled document base, which are those check sheets. You have duplicate and inconsistent forms, because when you have those Excel-based check sheets, everybody has a copy on their computer. They may have added stuff, they may have removed stuff that they just think, I'll remember. So you don't have any way of knowing that the knowledge they're looking at is even accurate. So your next model, you're getting a little closer to your active knowledge. So those first two were basically passive knowledge. There may be knowledge available, but it's only there if the person looks for it. So when we get to this hard-coded template parts, you have knowledge and parameters hard-coded into your seed parts, right? Your parametric templates. So you do have parameters, but they're hard-coded in the template. As far as reporting, you have your parameters, but they're hard-coded, so they're not flexible. If something happens, it's too bad. It kind of is what it is, because you put it in the part and that's the way it has to be. As far as knowledge management, you do have knowledge duplication basically from your design guides that may have been passively used in the past. You use that to put your parameters into your seed part. And as far as knowledge management, it's CAD system specific. So if you work in NX and you guys decide to go to CATIA, you got to do all of that all over again in CATIA. All that work that you just put in is for naught. And so now we're at our final level of maturity, which is our knowledge aware, which is we're using our knowledge actively in the designing process. So here you have knowledge and parameters that are dynamically provisioned in the parts and assemblies based on context clues. So what does that mean? You give context to your part, and by that context, it pulls the knowledge that's necessary to those designs right there in your model and, in your knowledge management software. As far as parameters, you have consistent and intelligent parameters that are across all projects. So no matter what project you're on, you don't have to worry about somebody making some new parameter because they thought it sounded better in their head. It's the same no matter what project you go to and what part you're designing on. They're also flexible and they're dynamic. So if there are new parameters that are added or maybe you need to make changes, you can do that because of the flexibility of the parameters. As far as knowledge management, your knowledge is gold source. Basically, that means your knowledge is coming from one place. You know that that knowledge is up to date, you know that it's relevant, and you know that it's needed to design your parts. And probably the best part is that it's CAD system agnostic. So just like I said before, you made this seed part in NX, but let's say you did it in X now, but you're like, oh, we're switching over to SolidWorks. That doesn't matter because your knowledge is set up where you can switch to whatever system you want to and it can still be used. So you're not duplicating that work if for whatever reason you need to change your CAD system. So you're probably like, what the heck is this CAD connector thing, right? So we have our next generation CAD connector. We have a screenshot right here of our NX CAD connector. So what does this Auros IQ CAD connector do? First, it's gonna drive or it's gonna check your parts and assemblies against requirements and standards from your knowledge source. It's also gonna connect CAD to your authoritative source of knowledge without copies. So when I said that your knowledge is gold source, it's coming from the same place every single time a part is modeled. Next, it's gonna provide automatic reporting of conformance to stakeholders. So as your part is being changed, your model is being updated, the conformance of those evaluations are happening in real time and you can see them automatically from anybody that's interested in that information. And then lastly, it creates parameter analytics and insight. So how we talked previously, when you have that passive model, you're going out, you may have those check sheets that you can do, but here it automatically gathers that for you. So if you need to see what's going on with these parameters, you can check them automatically. So right here, like I said, this screenshot is from our NX CAD connector, but this, because knowledge aware approach is CAD agnostic, we also have connectors for Creo, as well as SolidWorks or CATIA. They will all pretty much look exactly like this picture on the screen right here. So now that I've given you just a little bit of background on the CAD connector, you're probably like, how do I get this at my company? This is what I want to do, right? So we're gonna show you how to implement this in 3 easy stages. So the first stage we have is our dynamic parameter sheet. And this smart parameter sheet can be utilized without a connection to CAD, right? So it provides a consolidated view of your collection of knowledge parameters related to a model or an assembly while still providing instant access to the detailed knowledge source. So we do this step first for 3 reasons. The first reason is to verify your parameter naming strategy. The second reason is so that we can understand and confirm relationships across parameters. And the last reason is to verify the accuracy of the calculations and the evaluation outcomes. So now that I've given you just a little background on the stage 1, we're gonna go ahead and we are going to show a little video of the demo of what this will look like. Excuse me 1 second. All right. So for this first demo, we have our dynamic parameter sheet. To do this demo, we're gonna use a dumb part. So it's just a part that we designed. There's no parameters or anything pre-named. So we're gonna just take a look at this part right here. We're gonna use the inner cup for this demonstration. So first thing we're gonna do, we opened our model, we see our model. We're gonna go ahead and open our knowledge source, which for this demo will be Auros. The typical use case for this is you would have your CAD system on one screen or one side of your screen, and the other side you would have Auros. So once we get in Auros, we're gonna move to our community of practice. Here we have a list of knowledge packets or our captured knowledge that we also call K-packs. We're gonna open one of these up. And as we look into our K-pack, we see that you have an area to put in text, you have an area to put in multimedia to show dimensions that are being taken, as well as the multimedia and the text. We have our knowledge models, which we use value tables so that we can evaluate those parameters that are set up. And below, in our attribute section, we have categories that can be used as a system of tagging so that that knowledge can be delivered when necessary. What's highlighted right now are our parameters or our model knowledge, which is what's being evaluated between our knowledge source and our model. So if you look at the lightning bolt, that's our knowledge processing engine. If you go here, you can enter values for those parameters. And by clicking evaluate, it will evaluate those parameters based on the values reported. As you can see here, this was a fail. If you read that comment, it says, hey, this needs to be at least 2.5 millimeters. So we went ahead and we updated that value and clicked evaluate, and now you can see that that rule has been processed and now it passes. So we can click back to the details to see the original format, and we're gonna go ahead and close this. So what we're gonna do now is we're gonna open our assessment. And we're gonna do this by going to our dashboard, which was briefly talked about in some of our earlier sessions. So we're gonna click the My Dashboard icon, and this will show you any work that's assigned to you. So we're gonna go to our assessment page, and we're gonna find the assessment for our inner cup design. So as we open this assessment control, you can see it has a list of CAPACs similar to that list that we showed prior. This is the multimedia for the inner wall thickness that we looked at when we opened up that CAPAC on that first screen. As you can see, the lightning bolt is there. You can still access that to get to your knowledge processing engine within your assessment. So as you put in that reported values, it will automatically update your conformance state, which is being shown right here. You have your red, yellow, green. If you hover over those, it tells you when those conformances will be used. So now we're gonna go to our parameter sheet, which is what this whole first stage is about. As you can see, we have all of our parameters listed here that will be evaluated in this assessment. And if you expand them, you can see a link to the CAPAC or the knowledge that is related to that parameter. So from here, we're gonna go back to NX, and we just looked at, I believe it was our rib height. So we're gonna take the knowledge from our rib height, and we're gonna go ahead and we're gonna measure our model, or we're gonna look at the rib height now. Sorry about that. So now we're gonna look at the parameter for rib height. You can expand it, and you have access to the associated CAPAC right there. You can click that if you need to see the knowledge before you go back into your model. So here we see there's a range of 2 to 5 millimeters for that rib height. So now we're gonna close this and go back to our model, and we're gonna measure that rib height. And once we measure that rib height, we're gonna go ahead and take that, and we're gonna report that back to our assessment control. So now that we have our 1.87 millimeter rib height, we're gonna come here to our parameter sheet. We're gonna click in the reported values column, and we're gonna type in that 1.87 and hit enter. Now you see, as soon as we put that in, that square turned red, and you can see in your conformance state report that there's a red there. When you go back to your line item view, you can see that the line item associated to that parameter has automatically been updated. So here we're looking at the multimedia for our inner wall thickness. So we're gonna go ahead and we're gonna do the same thing for this, and we're gonna enter it another way. So here we're back at our model. We're gonna take a measure of our interior and exterior wall to determine that thickness. So now that we have our measure, we're gonna go back to our assessment in Auros. And instead of going to our parameter sheet, we're gonna go ahead and we're gonna hit that lightning bolt for that knowledge processing engine. And we're gonna put in our material, and then we're gonna put in that 2 millimeters that we just measured. So as you can see, the conformance state was updated to red, so that's a fail. So when we look here, we have a comment saying, hey, this wall thickness needs to be at least 2.5 millimeters. So now, not only do you get to know exactly when you put in your value what's going on, but you get to see what you need to fix it. So if you're trying to say, okay, well, this model was already 2 millimeters, what has this parameter been reported as previously? You click on that little chart, and this is basically your look across from your CAPACs, but for your parameters. So you can see, oh, this parameter value was this for these past assessments and these past projects. So if you can see if maybe that needs to change based on those reported values. So that is just a little bit, that's the end of our stage 1 demo. So this is just using that dynamic parameter sheet. You're not really connected to CAD. You're still using them independently, but you're able to take that information and enter it into your knowledge source. So next, we're gonna talk about stage 2 a little bit. And so stage 2 is your measure and your relation-based smart automation. So at this stage, we basically begin to automate the evaluation of parameters within the dynamic parameter sheet by establishing relationships between the features or dimensions or measures within your model or your assembly and the critical parameters from your knowledge source. So these persistent relationships will allow model values to be processed by the Auros knowledge processing engine, and when the model changes, those new values are then reevaluated. So we're gonna go ahead and we're gonna take a look at this next stage. So in this stage 2 demo, instead of using a dumb part, we're gonna use a parametric model. And for this demo, we're gonna focus on the outer cup instead of the inner cup from our first stage. So we're gonna open the sketch once we get into our outer cup model, and we're just gonna take a look at the system of dimensions that we have there. So when we open up, let's let There we go. So when we open up the sketch, you're gonna see that some of the dimensions have been renamed. So you see we have a center line diameter as well as a depression height. So within our parametric model, we've taken some of those dimensions and given it names. So now, since we have our sketch all set up and our outer cup selected, what we're gonna do is we're gonna open our knowledge source, which is an assessment control. So once again, we go back to my dashboard and we select the assessment for our outer cup. As you can see, the knowledge packets are different in this assessment control than they were in the previous stage because they're for a different part of the cup. So based on the context of the cup, we get different knowledge packets in our assessment. As you can see, if we click on the KPAC ID, we have access to the knowledge packet to see all of the information, multimedia, our knowledge models are available for us to see there. So now that we're back in NX, we're gonna hit the Auros tab, and we're gonna open the Auros connector. So on the screen now is our connector is connecting to your instance right here. Because our knowledge source is an assessment, we're gonna enter our assessment ID in that window there and click the magnifying glass, and we see that it has the 3 knowledge packets that were in there when we just looked at it. So we're gonna go ahead and we're gonna click apply. So once this is connected, we have this ring chart here that shows, hey, you have 3 parameters here, but they're incomplete. So we're gonna click on the assessment ID on the connector, and it's gonna open back up our assessment in Auros and show our dynamic parameter sheet. We're gonna switch over to our line item view where we have those KPACs listed. So now we're gonna go back to our model and we are going to create those 3 parameters. You see the warning on the bottom that says 3 parameters not found. So we click create and we have a list here showing you have 3 not found parameters. We also have a list for not connected and connected parameters, but currently they're at 0. So the first thing we're gonna do, we're gonna click apply, and basically what we're doing is we're creating parameters within NX from our knowledge source. And if you look in your part navigator on the left, you can see that those 3 KPAC IDs are now in your part navigator as well as the parameter names next to it. But if you look next to them, you see there's a little link there with a little zigzag, a little broken link. So it's showing, hey, you have these parameters connected. You have them created, but they're not connected. And if you look down on the bottom, you see that it says 3 parameters not connected now. So back in that same sheet, we see that those 3 from not found are now on connected. So we're gonna hit the pencil to connect those parameters. So the very first thing we're gonna do is we're gonna connect these parameters to a measure. So I believe the one we selected was the wall thickness. So we're gonna click the inside and the outside of the cup, and we have that measurement. Once we click OK, that previous expression is gonna show that this parameter equals this measurement value. You click OK again, it's gonna take us back to our NX connector, and it's gonna show that it's now updating that value saying, hey, this parameter is equal to this measure. So now you've just connected that parameter to a measure in your model. And if you see, the number from not connected went from 3 to 2, and the connected went from 0 to 1. And then when you come back to your ring chart, you see that now you have 1 item that's passed. And if you look in your part navigator, you can also see a colored circle next to where that broken link was, showing that it's connected and it's been evaluated as passing. So now that we have that 1 connected, let's go ahead and connect these other 2. So if you remember in our sketch at the beginning, we had a couple parameters that were already named. So here we're gonna use a formula to show the relation between the knowledge parameter to your model parameter. So we're gonna go ahead and type in depression height and click enter and click OK and click OK again. And we're gonna go right back to our connector, and it's gonna show that the connector is working, and it's showing that, hey, this parameter equals this parameter in the model, and it's building that relationship. And now it's connected, and you can see the connected number went up from 1 to 2, and not connected went down from 2 to 1. So we're gonna go ahead, and it also updated the part navigator to show a colored circle from that broken link, so you know that it's connected to the parameter you intended. So now we're gonna go ahead and we're gonna update this last not connected parameter, and we're gonna use a relation again because we have that other dimension that was named our center line diameter. So we're gonna put that in there, click OK and OK again. And when we get back into our connector, it's gonna show that it's updating that relationship between that newly created parameter and a parameter that's within your model. So now you see that there are 0 not connected, and now we have 3 connected parameters that when we initially started this weren't there. Now you have this little alert button, and that's basically saying, hey, this value in your model does not match your knowledge source. So if you go to your ring chart and click on that, you can expand and see, okay, I have a value of 4 millimeters, but Auros, or my knowledge source, says it should be 10 millimeters. So we need to go ahead and we need to update that because we need this part to pass, right? So we're gonna go back into our sketch and we're gonna find our depression height, since that's the parameter that wasn't matching. And we're gonna update that value from 4 to 10 millimeters. And once we update this, while this is being updated, we're gonna go ahead and we're gonna open back up our connector. And now the connector is saying, hey, it's a new value for this parameter. What's going on? Let me reevaluate this. And if we open that back up, we now see that we have 3 passing parameters within our ring chart. So in this whole demo, we've taken 3 parameters that weren't there. We created them. We built the relationships through measures and formulas using dimensions that were already named. And we were able to update those values in real time in our model, and it was able to reevaluate that value based on our knowledge source and update that ring chart to show that now this model passes all of the requirements based on our knowledge source. So now we've gotten our second stage done. So now we're on to where the real magic happens, right? That's what I'm gonna say. We have our stage 3, which is your smart parts with your key parameter management. So at this level of maturity, we have a better understanding of the knowledge parameters and their relationships to the models, right? So we begin to embed parameters into features and dimensions and constraints within the model. So by doing this, we can create smart parts. So these parts can be driven by knowledge instead of just being evaluated. So we can use the knowledge to drive the parts in our CAD system. This also allows the most efficient creation of your models and your assemblies while ensuring that the application of critical knowledge is done. So we're gonna go into this last video. So for this demo, we're gonna use another parametric model, but instead of the outer cup, we're gonna use the inner cup for this one. So once we get into NX and we select our inner cup, we're gonna go into our sketches, and we're gonna show that some of our dimensions within our model have been updated to the Auros parameter names. So if you look on the bottom, we got that inner bottom cup dimension, and I think we're gonna show one more other sketch where we have a couple more of our dimensions named with our knowledge source parameter names. So now we're gonna head into Auros, open up our assessment again. We're gonna hit that first assessment that we got from stage 1, which is our inner cup. As you can see, we have our knowledge packets in there. We have the same KPAC knowledge. So now we're doing a smart demonstration with the exact same knowledge we use for our stage 1. So we've all made it all the way to the 3rd stage, and we're still using that same knowledge that we made initially. So we still have access to our parameter sheet. So if you still like the parameter sheet and you want to come here and see all the parameters at once instead of going through the line items, you still have that option, even though now we're in a mature model with our smart parts. So now that we're back in NX, we're gonna go ahead and we're gonna open the Auros connector. So when we open our connector, per usual, it connects to our server, and then what we're gonna do is we're gonna tell it what the knowledge source is. So once again, it's an assessment, but hey, I don't remember the number, so I'm gonna search for it. I know that I was in a certain community of practice, so I'm gonna type in that community of practice, and then I'm gonna come down, click search, and then when I go and select assessments, I'm gonna use my project code and a short description that's on the assessment to find the assessment that I need to do, which in this case is 6272. So we're gonna click that, and we're gonna click apply, and once again, we have our pop-up showing, hey, we have our 7 knowledge packets and how many parameter evaluations we have, and that's correct, so we're gonna apply it. Now, since we have these smart models, these smart parts, and we've named our dimensions matching our knowledge source parameters, as you can see, automatic evaluation happened. When we did this the last stage, we had a gray circle, but now we have multiple states of evaluation within our circle. So as you can see, we have one parameter that's not found. So this will happen, maybe the last time this model was used, new knowledge has been added. So all you have to do now is I'm gonna create a new parameter to add this new knowledge parameter to my model. So like before, we create it, it's in not connected. We're gonna use a measure because obviously we don't have anything already named. So we're gonna go ahead and we're gonna measure this rib height so that we can tell Auros, hey, this measure is this parameter. So once we get that measure, we click OK, just like we did previously in stage 2. And we're gonna get that parameter connected, and we're gonna see that number go up from 8 to 9, just like it did. And now you see there's no gray section on your ring chart. Everything has been automatically evaluated within your model. Even your new parameter has been created, and now it's been evaluated. So if you click on the red, we get a list of all the parameters that are red, and we can expand those and click on the KPAC ID and access the knowledge in Auros to see what it should be. So we see here we have our wall thickness. So now we're gonna come back in here and we're gonna update these values within our model to then have them reevaluated to meet the knowledge that we have. Like from stage 1, when you see the alert, that just means, hey, this value doesn't match what you have in your knowledge source. And if you look over to the right, it'll show you what the Auros value is. So if you're like, man, I don't remember what it said, you can go in and you can update those values based on your Auros value. So we're gonna update these, and then we're gonna click apply. So now the new values are being reevaluated based on the knowledge source, and we'll see the ring value update as well as the model update. So now all of those reds have turned to green. So let's check on our yellow ones. We open up our yellow one, we click the pencil, and we can then update the value based on the knowledge source value that was shown previously. If we click apply, it'll go ahead and update that. And you'll see that the model as well as the ring chart will change. So now we have our model updated, and because our model was updated, now our assessment or our ring chart has shown, hey, this parameter is now passing. So you're like, okay, I got all my parameters done. I went ahead and I checked all my values, I updated them. So let me go ahead and let's update the assessment based on this model, which is what we're doing here. So now we open up our assessment and let's see what's going on. So we have our parameter sheet here. We have our reported value showing green and that one red. We can go to our line item view. We can see that all of our line items, the conformance states have been automatically updated, and we've only been in our model. We haven't really touched this assessment. So now you've gotten an email from your boss. He's like, hey, I know you just finished doing that acrylic tumbler, but you know what? We're trying to get off acrylic. Let's do stainless steel. Maybe they want to put some hot stuff in here and cold. So we're gonna go ahead and we're gonna update this model. So we need to tell the model, hey, we're gonna switch from acrylic to stainless steel. So now we're updating our model. And while we're updating our model, you see that the connector is working. So basically what happens now is the context on the model is updating our knowledge source. So as you can see, the number in the middle has changed because now the material is different, the context has changed. So that means there's different knowledge that needs to be applied because acrylic, standards for acrylic are different for stainless steel. So if you looked at your parameter sheet, you see that those have updated. You see that your inputs have changed from acrylic to stainless steel. And you can see that your conformance states have updated in your assessment based on the changes in your model. So we go to the one that's red and we see, okay, we gotta fix this inner weld flange. So now we're gonna come back here, we're gonna click on the red in our ring chart, expand to see what the new value is based on the old value. As you can see, you have your alert telling you these ones need to be updated. So we're gonna go ahead and we're gonna update these values from 3 to the new values that are needed for our stainless steel. We're gonna click apply. And while that's being reevaluated, we're gonna see our ring chart update as well as our model update. So let's open our ring chart back up. And now we went from having 2 red to now they're all green. So now we can go ahead and say, let's update the assessment from this model. So we click them all, we click update assessment from the model. And it's writing all this information back to your knowledge source, which is our assessment control. So what's really cool about this is by having your parameters and your smart parts set up, we only really worked in our model. So once you open your assessment and you have it set up, you can work directly in your model and the changes in your model will drive what knowledge is in your assessment. So even though we started with acrylic and halfway through or towards the end, we realized we had to change, there was no change to the knowledge. The knowledge that we needed was still there. It was changed, but it was based on the context of the model. So now that I'm changing, I don't have to go find, let me find the stainless steel design guide. I changed my model, the knowledge was updated. Now I know that I have the knowledge needed to finish this. So that is the end of our demos. So are there any questions from anyone? Yes? Okay. Oh, Lord.
Yes. No, it's great.
Y'all trying to make me work, huh?
Oh, Kamyle, you're cute. I'll just read them to you, okay?
Okay, sounds good.
Okay. Is there a particular version of NX SolidWorks CATIA that is required to connect to SmartCAD?
No, whatever version you have, we can have a connector for that version. There's small differences between versions, but it doesn't really matter what version you have. If you have those CAD systems, you can get a connector from Auros.
Great. Next question. Can SmartCAD be used to evaluate assemblies and installations, multiple assemblies, and can it assess 2D prints?
It can. I know we showed just the individual parts for the demo, but all throughout this, I've been speaking on assemblies as well. So it can, if you have it in CAD, we can evaluate it.
Great. Next question. These are clipping through. Can you flip between CAD systems, such as having models in AutoCAD and NX, and glean insights overall?
I don't know about AutoCAD. I haven't had, I'm not gonna lie, I haven't had any experience with AutoCAD and the connector, but if you do have different CAD systems, as long as the parameter naming is matching your knowledge source from your model to your knowledge source, then you can use a connector for either one and get the same results. So as long as you have the parameter names and the relationship set up, it doesn't matter which CAD system you use.
Okay, great. And it sounds like our fourth online question got answered already,
Okay.
that Autodesk and AutoCAD are supported. Yeah.
Yes, yep.
Yeah.
We have connector for those as well.
Okay, good.
Yes.
Thank you.
So-
Now, any other questions?
Yeah, my question is just how you name the parameters. You have some limitations there. So you showed some descriptive line, and I'm not familiar with that, so I don't know how much of a description can you add to each parameter.
So for the parameters, so in stage one is where we'll come up with the naming strategy. So we can kind of set up what words are necessary. We can't really have like a ton of spacing and stuff, obviously, in parameter namings. So it's limited. I'm not sure of the character limit. Do you know if there's a character limit? I'm not sure. I don't know if there's a character limit, but obviously we don't want a sentence for every single parameter. But in stage one is where we can set up, okay, we need, for this instance, we have a cup. So we need to know its inner cup. We need to know if it's a wall thickness. We need to know if it's a rib. We need to know if it's a weld. So you can take kind of your main descriptors and just put them together, and you can set up a strategy. So moving forward, as new knowledge is added, you can follow that same strategy. I don't know if that helps. Are you talking about in NX or are you talking about in Auros?
I think he's talking about end user messaging.
End user messaging? Is that what you're talking about? The comment?
It was mainly, you've kind of addressed it with
Okay.
just a standard, using a standard approach.
Yeah. So yeah, that
In
stage one
Auros.
is very important, because if you don't get that naming strategy set up and you just say, oh, you just go willy-nilly, it's gonna be very hard to make those relationships later. And when new knowledge is added, people will just put in what they want, which is
Okay.
always bad.
Thanks.
No problem.
Thank you. Yes.
Oh, we got one more question right there.
A couple rows back. Yep.
So I saw in the parameters that you created for the cup that the dimensions were basically linked to 2D measurements, and then basically the whole cup was made with an extrusion, so every feature of the cup was a dimension. What about assessing features of CAD that aren't made in a sketch, like a shell command? Like, I've got to work on injection molding, so going for a wall thickness, I'd shell my part out. How would that be linked to a parameter?
So you can link parameters through measures as well as the formula. So let's say you don't necessarily have a dimension name for that, but you have the model. You can say this wall thickness is equal to this measure. So you would just have to open up the model, take the measure, and say, hey, this measure here is what this parameter means. So you don't necessarily have to have a name there, but you can still connect those parameters.
Any other questions before we wrap? Yes, Jo Beth.
You showed the connection from CAD to Auros, but can't you also drive from an assessment to the CAD model and make
Yes.
manipulations too?
Yes. So you can update the parameters within your assessment, and you can get that connected to your model as well. But usually, if you're designing, you're in your CAD system. So most times you'll be in your model, updating your model, and then you can send it back. But you can do it the opposite way as well. Oh, Steve was saying that's done a lot for concept phases. So if you're trying to figure stuff out, you can update your knowledge to update your model. Any more?
Okay, I think that wraps us
All
out.
right.
Thanks, Kamyle.
Thank you.